Welcome to Season 13 of the Prosthetics and Orthotics Podcast. This is where we connect with experts in the field, patients who use these devices, physical therapists, and the vendors who help bring it all together. Our mission remains the same: to share stories, tips, and insights that help improve patient outcomes. Tune in and join the conversation. We're glad you're here and hope it's the highlight of your day.
Hello, everyone. My name is Maurice Peels, and this is another episode of the Prosthetics and Orthotics Podcast with Brent Wright. How you doing, Brent?
Hey, Yoris, I'm doing well, man. Funny enough, supposedly, like the Midwest has been in an Arctic freeze, and I'm guessing, do you get snow in Spain? I'm guessing not, but maybe.
Not really. Don't worry. Everybody would be really kind of worried if we got snow around here, I think.
So anyway, it's coming to the South and the Southeast, and so there is no bread or milk in the grocery stores, because that's just what we do. We go buy bread, milk, and all the toilet paper.
Yeah, all the toilet paper disappeared. It's really funny. Do you know that? But it's all psychological, this stuff. Like, you know how everybody, like how all the toilet paper in the world disappeared at one point with the global health emergency? Right?
Yeah.
And except for in Holland, it didn't happen because there's one guy on he was on what is it, one of those forklift, right? And he just drove around while playing like a really cool song. He drove around a toilet paper factory, showing people like there was like holes and holes and holes of toilet paper everywhere. And then it was like, yeah, we're not going to run out. And then so it didn't run out for a while in Holland as well. That was just that one guy with his little viral video. But yeah, it's a very normal thing to see. I think all this panic buying. Hope it's over pretty soon.
Yeah. So, well, I'm excited about today. Today's going to be a good one. So we have Maurice Johnson from Floyd Brace and Limb. It's a company that's been around, that has a lot of history. And so I'm really excited about hearing from him about kind of the journey so far. And they've done a lot of stuff in the digital space. And so I'm kind of curious on some lessons learned, some things that they might do different. And I think our listeners are just going to get a lot from it, because not only are they a regional company, but they also are smaller as far as like more of a family-owned company. And so those decisions that they make can also have a greater impact on what other people and potentially may make. And so I'm excited just to hear about, what's value, what's not valuable, and then and go from there.
Awesome. So welcome to the show, Maurice.
Thank you for having me. How are you?
I'm good. We're both all good, I think. And how are yourself?
Man, I'm doing good. I tell you, Jared got me on this call this morning without expecting it. I will tell you, Floyd Brace, can I tell you more about our company and kind of tell you how we got where we are? Floyd Brace has been around since 1942.
Wow. Yeah.
When I started at Floyd Brace Company, and I started here in 1993, Floyd Brace had one office in Charleston. We had two technicians, fabricated prosthetics. We handmade Charleston bending braces. We handmade everything. I actually was hired as a technician. I'm an Army trained orthotist. I was trained in the Army at Walter Reed Army Medical Center. And again, I was probably more of a technician when I started. I later got BOC certified, eventually went back to school. I got my master's in orthotics and prosthetics, but I've always only done orthotics. When we look at the fabrication processes, and I think that's where we are right now. Like I said, we did everything by hand, and it was our goal at Floyd Brace Company to centralize some of our fabrication techniques. And we started by 3D printing our prosthetic sockets. The challenge that we still face is finding an economical way to still 3D print and provide good margins in the O&P space and still 3D print. Ask me a question.
No problem. So when you look at 3D printing, like I think, why did you start looking at it? Was it a cost thing that you wanted to do? Did you want less labor? Did you think it would fit better? What were the real reasons why you did it? And how'd you go about it?
Okay. So I'll tell you as an owner of a company why we did it. So we always had systems in the orthotic space. We always central fabbed in the orthotic space. So I'd evaluate somebody, get a cast and send it out. I was trying to find duplicatable systems within the prosthetic space I don't believe clinicians should be fabricating. I believe that clinicians that are in the back fabricating are not in the front seeing patients. And if a clinician is in the back fabricating, they're not making money for the company. So I was trying to find a system whereas my clinicians could, I'm not trying to make it like, I'm trying to find a duplicatable system for fabrication for the prosthetic space like I did on the orthotic side.
Mhm.
So that's when we started 3D printing. Go ahead, ask me.
Okay, and you didn't look at it for orthoses because we are seeing a lot of people look at orthoses and 3D printing orthoses because it kind of is easy and all that. Did you look at that at all or not really?
Yeah, we tried to find orthotics, but so who has the system? Who has a system to scan? Who has a system to modify? And then who has a system to 3D print? There's no system out there that you could do all three of them that you could present to an O&P company and tell every clinician this is the system on which you do it.
So
It takes
literally, like your
the
ideal
print.
solution would be like, Bob's scanning or whatever, one size fits all, one number to call, one press of a button kind of system, not like a bunch of different vendors, different material. You don't want to like have to change anything. You just want it to work from day one, right?
Brent special. There are not a lot of Brents in our P industry. Brent could do, he knows a system to scan. He knows a system to modify, and he has a system in which he could 3D print. The average O&P clinician coming out of school doesn't understand that you don't want a clinician having to jump between 3-4 different softwares to get one device fabricated. That's the problem with the industry. It's all fragmented right now.
I think that's a really great. I think that's a really great point to make. I mean, you don't want that from your point of view. Like clinicians should be clinicianing, let's say, and
Yes.
fabricators should be fabricating. Like you don't want them just messing about with like, start a software, another software, change it. And I guess also from a maintenance point of view, you don't want to like call a guy and say, "Oh no, the problem's not on the material.
Yeah.
it's the printer. It's not us."
So
I understand that point of view.
So we went a year meeting weekly, trying to figure out a system in which to operate. Okay, so let me give you some history here. Okay, so we did everything by hand. About 5 years ago is when we started. We started buying. So I have everything in O&P. I have a carver. I have the Roboticom carver, and we bought the carver because we wanted to eliminate plaster. Then we also have Vorum's software for candid for fabricating, for modifying. We have the foot orthotic for Freedom foot orthotic for custom fabricating foot orthotics. We have 4 CNC machines for carving foot orthotics. So my point in saying all this is in the process of trying to find a solution, we bought everything that's out there in the market. We have, what's the machine called? Brent, what's that thing called to modify by hand?
The haptic device?
We have the haptic device. So we bought everything out there just to find solutions for the clinical staff. But again, like I was saying, there is no system that's out there that's not without clinicians going from one space to the other. So we went through a process of elimination, trying to find a solution to get things fabricated. And my goal was to not have the central fab. So I didn't say that part. I was trying to get from around central fabrication because of the costs associated with central fabrication, and also to get quicker turnaround times on our orthotics.
But that seems a really sensible approach. What's interesting to note, by the way, is that in dental, for example, there are these solutions where they say, hey, we'll send you the machine, the post-processing equipment, the software, all from us, all with the same manuals, all with the same training and everything. So in dental, this does exist. So I think in O&P, we just need a little bit more maturity, and maybe at one point somebody will offer that solution. But I think, especially for people like the Poto printer guys, Equal and stuff like that, that I think is the place they need to be at that place where they could be this one-stop shop from acquisition to fitting, let's say.
So Joris, is it Joris or
something like that? It's fine. Joris is fine.
So how are you going to do it though? Because remember this, in dental, nobody's going to weight bear on a denture. Nobody's going to weight bear on this stuff. So the problems that we're having. So we've looked at the HP printer. So what's the problem with the HP printer? HP printer, how many devices are you going to be able to print in one run and it still be cost effective?
Yep, exactly. Hit the nail on the head. That is totally the issue with that thing. If you have a constant volume of devices all the time, that thing is going to make money for you. That is going to be great for everyone. And if you have a lot of fluctuation where you don't hit that constant volume, it is going to be a huge weight on your bottom line. Completely agree. That is the shortest summation of the issue with the MJF. And also the other issue is that if you have a little bit more than one machine can be filled, then also it's suboptimal, right? So if your volume measures what you can get from that one machine or from 2 or 3 or whatever, then it's absolutely beautiful business. But I agree, you hit the nail right on the head there. That's the big issue with these bigger machines.
Okay. So currently we're using every prosthetic, 90% of our prosthetic sockets are 3D printed. And how that system works, clinicians still cast. They scan inside the cast to modify using Omega's Willowwood software, upload it to Omega Willowwood, modify it, and then we're 3D printing a check socket or test socket. We're fitting that test socket. And again, we have 7 offices in the state, about to have 10, and they're fitting those test sockets, wrapping the test socket with fiberglass, but we're still fabricating the definitive by hand out of carbon fiber.
Yeah, I'm kind of curious on that aspect. Maurice, is so when does when you're looking at all the spreadsheets and all that stuff of the actual value, because when you have carbon fiber and you have the labor to do that, you're I would say fairly cost effective on the material cost of things, not considering the technician's time and all that stuff. But where do you see what would be the tipping point for you when you're looking at the financial aspect of that?
And what do you mean? So you're talking about the cost?
So you're doing all your check sockets. So you've seen a financial value of doing the check sockets in-house. You're turning around stuff quick. How about when it comes to definitive? When would you say, yes, now it makes sense? Or what is your criteria that you would use to say, yes, now is the time?
So let me help you first. So I'm trying to grow our company. So I do understand that there are going to be more costs associated right now with trying to find a solution. So we currently, and this is the other thing I didn't tell you, Brent, we're central fabbing most of our definitives. We're not necessarily making those in-house. So those costs are staying about the same as they were before. So majority of the definitive sockets are being fabricated centrally fabricated. My goal, however, was to see how could we 3D print a definitive socket and save costs on the 3D printing of a definitive socket. There's no such animal unless do you know of one?
So I think that's so when you say central fab, you're central fabbing somebody outside of Floyd or like Floyd. Okay.
No, somebody outside of Floyd.
Okay. So I think probably, my guess is that you would be, and I'm just making an assumption, is looking at some sort of lateral move financially, potentially, hey, can we turn it around a little bit quicker into the 3D printing space? And that's what would actually start tipping the scale. And then as volume would increase, you either bring it in-house via machine or the volume increases on the central fab side where your pricing keeps on getting better at scale.
No.
Okay.
So I will tell you that the problem again with that, I've even looked at using a print farm to print definitive sockets. And actually the cost is more than having it laminated.
So, but if it wasn't.
Yeah, what was it?
If it wasn't I don't know. I mean, I guess I don't know how much you want to share or don't want to share, but is there a number in your mind? Hey, if I can get a definitive socket and then a definitive socket in with a flexible inner under this much, then stuff gets interesting.
Yeah. What do we pay now? Yeah. I think we pay between $700 and $800 and sometimes it's $1,000, depends on who you're getting it for. It was my hope, which is unrealistic, that you can do a socket for $500-$600 3D printing, and there's no such thing.
Man, it's been a while since we talked, Maurice. Maybe offline off this one. Yeah. So anyway, I mean, that's an interesting thing. So I think that's pretty much what I'm seeing on the contract manufacturing side of things is a carbon fiber socket is going to run you anywhere between, depending on the size and components, $5,000 for transtibials. Nothing too crazy like adjustability and that sort of thing. So,
So can I make a point though?
yeah,
So can I tell you what my goal was though?
yeah, sure.
So my goal is, so we have new clinicians, we have residents, and my goal was to find a solution, like I said, that's duplicatable, but software is also the issue. Wouldn't you say software is an issue? I mean, you could 3D print all day long, but you got to get to that point. You can't get to that point with somebody right out of school. You can't get to that point with CanFit. Then we got Omega. Then we have, man, our company's tried multiple softwares. There's no solution. What are you using now? We've done, what did Josh do? Josh did, yeah.
Yeah, you've done a lot. So I think this is where things get really interesting. And I actually obviously we've got Jared back in the background there too, a little bit listening in. And, I think one of the things that I think I'm really proud of what you guys have going is that you're looking for clinically relevant solutions that can be replicatable as you scale and grow. And so one of those solutions, and I can just speak from personal experience, and I can't wait for you guys to get your hands on it. But I would say that I was a little bit skeptical at first on the AirFit system, right, for transtibial sockets. So transtibial sockets make up a pretty large percentage of all the prosthetic sockets in the United States compared to, say, transfemoral. And one of the things that I believed, as my belief along the way, was how can I create a socket with my hands that fit all the patients?
Yeah.
And the reality is I can do that, right? So I am one person, I can do that, but I am not available to be in multiple offices like what you're scaling now.
Yeah.
So one of the things that I think is so great, and one of the things that has been challenging for me because of the work that I do in Guatemala and some of the developing world stuff, is how do you scale that side to be as close to software free as possible, right? So for transtibials, I'm talking specifically for transtibials. What I've found with the AirFit system that gets me so excited is no matter the limb shape and no matter how they present, how gnarly it is, I've been in the ballpark, I would say hitting a home run every single time with that system. And I'm into the double digits now with that system just over the last few months. And so that to me is very interesting, because if you can do the transtibial sides and say scan, regardless of scanner or what have you, and literally it's a smooth of the model alignment, which is a clinical decision, and then into your test socket, into your definitive, what that does is everybody, like if you're going to 10 offices, everybody gets on the same page and everybody knows what the results will be from that sort of situation. And that then takes the overall pressure down, and you can really focus in on some of the other things that aren't so cookie cutter, like transfemoral socket, even though we're working on that side, or some of the dynamic AFOs, things of that nature. But it's almost like a pressure valve. You've taken this pressure valve of a high volume thing and made it very clinically relevant, but consistent to where you're successful. You're minimizing follow-up appointments, any skin issues, things of that nature. And to me, that's what's exciting, is how can we get to that point where that cast or that image is what you're going for in the final socket.
So Brent, so you're saying we're going from cast to socket to definitive with this system? I'm confused.
Yes.
So
Yes.
You're saying we're not using software. The software component is out of there.
For transtibials, you can scan and smooth and go straight into an automation to create the sockets, and you're done. Yes. So you may smooth in, whatever software you want. And I'm happy to share more about what we're trying to do on the cost-effective side of things.
Yeah.
For the smoothing and the alignment side, which is a clinical input. But I haven't even done I have fit the last 7 patients that I've done. I went straight to definitive. I didn't even do a test socket. And these are like gnarly, like crazy limbs that you would think that this would be a 2 or 3 test socket deal. And that was not the case at all.
Yeah.
But that's what's exciting, is that you could do it Jared could do it, the new resident could do it, and they would be the exact same as what I would do. And I think that's the exciting part, is this hybrid. It doesn't take away from what we do clinically. It's just that we're front loading all that information in, so we don't have that middle section of guessing essentially the modifications and then doing it. And then you go into the test socket and then the definitive. And I think that's the exciting part, is we're putting the value of the data front loaded by the clinician to create the output that we want.
And then Brent, if okay, that sounds great. You should get these AirFix people to pay you. You should be like a spokesperson. Hi, my name is. I'm the spokesperson for AirFit. And then what would you advise for them later on? What could they be looking at if he wants to get the cost down? This seems sensible, right? AirFit sensible. What would you advise for them? Like, if you go later into like actual making the things, like should he look at a print farm type of thing? Should he look at maybe you could outsource it still? What would be the solutions? If you're like like these guys, you're looking at cost. What do you want?
Yeah, I mean, I think the biggest thing is being laser focused on where to save the biggest amount of time. So yes, can you find a 3D printing socket for $500 to $800? Yes. But what about those sockets that do reimburse better? Say something with a adjustability or something to that effect. That would be a pretty interesting way to do it, because not only is your turnaround quick, but your access to a clinically relevant, good patient outcome thing with the adjustability and a higher reimbursement, that time gets compressed between the start to the finish where you actually get your money. And I think there's a lot of value in that. And so there's different ways to do that. Yes, there's bigger machines that you could put multiple things in, but then yours, we've talked about it. The Formlabs Fuse 1 with nitrogen runs like we call it our nitro material, which is the PK 5000. You can almost fit most transtibials into that socket or into that machine, and it's a very cost-effective machine to run. And then maybe that's the way you start, is, hey, on the ones that we can fit into the machine, we're going to drive our material cost down to next to, a really good value. And then we're going to outsource the bigger ones to get rolling, and then just see where that takes you. And I think that gets very interesting.
So we looked at Formlabs. Mm-hmm. And the problem I had with Formlabs is, we're in the South, man. There are not a lot of people whose socket is the size that'll fit into a Formlabs 3D printer. Again, I looked at my MJF and SLS. Mm-hmm. My opinion, and my very little research, you're going to get a similar product. I've also found that SLS printers you can find for a whole lot less expensive than the multi-jet fusion, which HP has. Again, the Formlabs, when we looked at the Formlabs, is just too small. It's just not, how many sockets you want to get out of Formlabs?
Yeah, but if your material cost is $150 or less, that might be something worth looking at. So
but how long does it take to print a Formlabs socket?
You would be, with the Fuse 1 Plus, I think you're into that part in under 24 hours.
Okay. So this is the point I'm trying to make. For a company that has 7 locations that's fitting sockets every day, how many of those are you going to need just to make that one system throughout your whole company? Every office will have 10. Will I need 10 of those just to support my company? That's the problem. The problem we have.
So I think these are good discussions to have. But I think so. What really
I'm not trying to back you in the corner, but I'm just telling you, we've looked at all of this.
This is the way that I look at it. So if I know that my material cost, I'm just going to use $150. It could be less, could be a little bit more. I can't believe it would be much more than that, just because of this is a smaller build chamber. But let's just pretend that you are able to get, let's call it 3 adjustable sockets into that machine a week. We're not struggling hard. This is during the day, you're harvesting, all that stuff. So you have generated.
Can we do this? Can we not say adjustable socket? Can we say just a regular socket?
Well, I want to. So yeah, we can say a regular socket, but the adjustable socket gets really interesting because now you're spread between what you are already going to have for a socket, a regular socket. Let's call it $600 to $800 that you've got your sunk cost into that. You're already going to pay that no matter what.
Yeah.
Let's say for another $600, say you're in the $1,200 to $1,400 range, that's assembled adjustable socket. That would be your cost if you contract manufacture. But now your spread is $3,000 more plus your base codes. Now we're talking a pretty good spread. If you bring it in-house, it's even a much better spread because then you're only looking at your material costs and your cost of goods for, say, bringing the reels in. And so that spread can literally be thousands of dollars. And if you do 3 of those a week, 12 of those a month, you are printing money at that point.
I get that part, but this is my problem with the adjustable socket. Because I've thought about this, the same exact thing. Am I going to tell every clinician that works for me to put everybody in an adjustable socket? How ethical is that?
I mean,
this is another discussion.
This
is another discussion for another day. But I will tell you, when the idea of being able to put or bill for the adjustable socket was out there, am I supposed to tell every clinician to put everybody in an adjustable socket? That's why I wanted to do it based on a regular socket to see if that'll pay for it before I even did.
Yeah. Well, I think there's meat on the bone. I was just saying that there's a lot of meat on the bone when you're talking adjustable. And then, I mean, would you say that many of your patients wear socks and change socks throughout the day?
That's a good one there, Ben. Yes.
Okay. So if they had the opportunity to adjust and not use socks, is that the right thing to do for the patient?
That is the right thing to do.
Okay.
So again, I'm an orthotist. Go ahead.
Yeah. So the bottom line is, you absolutely, as an owner of a company, should not dictate whether you're a prosthetist, orthotist, or what have you, your clinician's decisions. But I can just say from, say, an East Point side of things, is if the patient has the ability to think about that, and if they do change in volume, it is absolutely the ethical thing to do to get them an adjustable socket. But we're not going to mandate that.
Yeah,
but we have created a system to where, those sockets, if you traditionally fab them in-house, you're talking about an 8-hour day for a technician for one socket. And if you outsource that, you're going to get hammered. These are $2,500, $2,500 sockets. There's no meat on the bone after that. And you're pretty exposed financially, especially if you don't get the code for the adjustability. But if you have that same ability to put adjustability on, and it costs you the same amount other than the reel to make, but it takes a little bit more on the design side of things, you are not leveraged like you would be in a contract manufacturing side of things. And so from the financial sense, that's where it makes sense, but it's also the right thing for the patient. That's why I love the adjustable socket thing. But yes, as far as can you, for the sockets, let's just say you did 20% of your sockets in the Form Labs, which I know you would want to do more, but the ones that could fit in, your material costs at $150 a piece, you're still saving, say, let's call it $400 pretty easily per socket. You would easily be able to pay for a system within a matter of months.
So let's build my system for your listeners.
Yours is loving this, isn't it?
I'm loving it. This is like literally my favorite episode so far. This is wonderful. I love it.
So let's build my system.
No, I love the honesty. I think this is great. This is wonderful. Yep.
So we're saying we could use what's the system called? The AirFit. All right. So we get a model with the AirFit. We scan the inside of that model with a scanning app or the Combs app or the iScan.
Yep.
Right. And we're going from there to a definitive, correct?
So it depends on how you want to work it. So I'm not saying, I am comfortable going to a definitive, but it's going to take some of the other clinicians, especially if you don't know the system well,
Yeah.
or you say, let's just say you didn't pump it up enough or something
Okay.
to that effect.
All
And
right.
you're going to have to throw in a pad, or you just don't
Yep.
want to go into definitive right away.
Yep.
It's okay to go to a test socket. So the system would be AirFit, scan,
Yeah.
software, and there's simple software to align, smooth. If you have a wrinkle in your model or something, you could definitely take that out. And from there, the socket is automatically generated and it goes straight onto your 3D printer.
Okay. So the adjustable comes in
So the
for the
adjustable
definitive.
Yes. Yep. Now you could do if you wanted to just see how the adjustable works you could do a surface mount, and you could keep those around for test sockets. So whether you do a posterior hinge style or you're cutting out a multi-panel type of thing, you could do that, take a little bit more work, or you could print that. It wouldn't be as automated to get the panels out. Now that you say that, we could make that automated, but so you could get a test socket and print those panels out. But that's the way that you would check to say, okay, is this, and if that helped you feel better about the process, that you actually are trying the adjustability in the check socket, I think that's a win.
Okay. So for your listeners, we've ordered the AirFit system.
Yep.
FYI, Jared is going to come on here after he uses it. And I'm going to get, you hear me, Brent? I'm going to get a Formlabs 3D printer.
Wow, very good. No, I think for your setup and the volume, I think it's tantalizingly close to making a lot of sense. But the thing is, I think you were looking for a one-size-fits-all kind of solution, and we're just not. I don't think we have that maturity at the moment. It's kind of like when they used to make Model T kind of vehicles, and it only took a couple of years before anybody started having a vehicle that you could adjust to make it into a delivery van, an ice van, and a repair van, and all these things, And we're just not there with exactly having the total lineup that you would need to just have you phone, and that's why you can make money with this. It's because you are in essence a pioneer, because it isn't as easy as just ordering, doing an online training, and then off to the races. It is still difficult,
Yeah. And I think, Maurice, you hit the nail on the head, though. You have a Jared, right? People like Jared don't grow on trees. So having the human capital to do that, and the passion behind it, somebody that's not going to be like 5:01, it's time for me to go, head out the door. That's a big deal. And, not all companies have that luxury in that. So, but I think what this has shown is it is a pain, right? It's a pain point for many business owners, and there's not a great solution that covers it all. But it also shows that our field it's unlike aerospace. It's unlike other things because our patients are moving targets. They're getting smaller. They're getting bigger throughout the day. They don't show up for appointments. They all of a sudden show up for appointments. We have insurance things. It's that whole package is a difficult one to solve. It's a difficult problem to solve. And taking that first step, sometimes, you've found that out. I think you Maurice, you and I might have be very close to the amount of money spent trying to figure out solutions.
I have everything. I have everything. Everything there's out there, I have. So as we talk right now, I'm sitting here thinking of a system, because I have clinicians who are definitely not like Jared. I have one clinician, he loves to do everything by hand. But for me, as a growing business owner, I'm trying to find a system that when somebody leaves Floyd Brace Company with the socket, it's a unique socket to Floyd Brace Company.
Mm-hmm.
And I want something that everybody, I won't say everybody, because every clinician makes something different and everything looks a little differently, but I want something that's unique to the company that everybody, and I'm talking as a business owner, I'm not talking as a clinician, that I want everybody to want. I want everybody to want my system. I want everybody to be able to get in and be serviced faster than normal. So I think my AirFit system, my Formlabs printer, and all that combination might help us. I don't know.
Yeah, well, since we've been so honest, and I could start here, but how important is cash flow to you?
My goodness, I need it.
Yeah.
Yes.
Yeah. So if you can shave 2 weeks off a delivery time, there's value to that.
Yes.
Or because you get your money 2 weeks earlier.
Yes. Yes. That's the goal.
Okay.
That's the goal.
So I think, and we don't get into this as much, and yours just for you, and then we have some non-clinicians that listen to this too, that wonder why it's so hard to even sell into the orthotic and prosthetic industry. Even if the product is better, you're not waiting an extra 2 weeks if you can do it traditionally. Is that a fair statement? Right.
That's fair.
We cannot wait on the cash flow. We've already sunk in clinician time, parts. A lot of times we've already paid the invoice, the net 30. So if the real trick, and I think the opportunity for additive manufacturing, is to tell the story to business owners and to deliver that, hey, this item that currently takes you this amount of time, we can squeeze that time down and get you great patient outcomes, great clinical outcomes, and your money faster. That's a good story to tell.
I think that's a really great story. And okay, so let's talk about this case a little bit more, because I think this is really cool. Like, given the setup here, given what Maurice's infrastructure is and what he wants to do, like, there could be two other options, and Maurice already talked about it. Like, one is a print farm kind of thing, and the other one would be kind of like getting an Equal or a Proteor, like a Filament Innovations, larger material extrusion system kind of thing. Would you recommend either one of those, Brent, as an alternative path? Because see, on the if we're looking at this as a capex kind of cash flow type of deal, right? What can we invest now, which is limited because we have limited cash flow generally and limited margins? And also, in the same sense, what can generate me more cash in the future in an incremental way, that with an investment that is manageable today? Then, material extrusion with these cheaper desktop printers that are less capable, but could be very capable for certain things, or less capable of details, essentially, or like a much larger kind of like pellet-based or other kind of system. We could be making a lot of low-cost parts as well. Would you recommend that as well in this setup, or would you say, you know what, go with the Formlabs and then that'll really get you the value, and then later on maybe look at these other things?
Boy, Joris, you know how to ask the questions, don't you?
Now we're going. So Brent, I gotta agree with him, because this is the other thing that you're talking the Icarus printer, correct? The filament.
Yeah, totally. That's a really
like any 3D printer that prints either pellets or
yeah.
So
anyway, Equal, Proteor, whatever they have. We had a lot of Filament Innovation guys on, and that is a really great, robust system.
Yeah,
and it's not super expensive,
and its
larger. Costs are not really high. And you've got me all worried about how big Southern people are. So,
but you're also talking about a larger something printer that I could print TLSOs in as well. There's some more orthotic stuff that you could do in that larger printer. Am I wrong or right, Brent?
So one of the things that I
wouldn't, but that's interesting. That's really interesting you said that. But yeah, go on, Brent. Yeah.
So one of the things, and I don't think I've ever said this on the show, so one of the things about powder bed fusion TPU is that it goes through 3 thermal cycles. So the first one being the printing process, the second one being the dyeing process, and the third one being the vapor polishing process. At any time in those 3 cycles, you potentially can run into tolerance issues. And it just is what it is. And we got tired of that. And I've never said this on the show, but we have actually started moving away from powder bed fusion TPU for most of our sockets, because we have, I would say, the best FDM wizard in the world he's able to dial in settings on printers and that sort of thing. So we've gone and we've significantly, and Maurice, we can talk further about this too, but for flexible inner sockets, we have lowered the price so much by doing it that way, using material extrusion or fused deposition modeling. And I learned from yours last week that it's material extrusion. We're trying to get better about that. But using
no. People are making fun of me for that. This is like defensive. Don't worry. I wasn't trying to make you feel bad.
So all that to say is, with some of these lower cost printers, I'm talking Bamboo H2S, Bamboo H2D, the Creality K1 Max, even the Neptune Elegoo, whatever, Max. Those are capable of producing beautiful, flexible inners that you can be proud of, that have the lattice structures that we've been using with powder bed fusion, and they just flat out work. And so we've been doing that for probably, about the last year, and it's been pretty incredible. So all that to say, when you're taking a look at your actual costs, taking the powder aspect out of the TPU
Mm-hmm.
lowers your material costs significantly for a wonderful end use product. And we're really excited about that. So still have your frame with the nitro material, the PK, but you're doing a material extrusion flexible inner that then, if you choose not to do adjustability, guess what? If they go up to 5-ply and they're consistent, you just reprint one of those flexible inners and reduce it 5-ply, and you're off to the races. And you could do that. I mean, you could charge for it, or you could do it for free, and you would be out next to nothing other than a little bit of design time. And that's what we are excited about.
Yeah, I think that's amazing, Bob. I think that's a really amazing approach. But that is like, you're changing your system, your entire design system, your workflow to figure out, like, to work within the realities of the manufacturability of these devices at this point. You're kind of zigzagging through this process. I think that's really great. And on top of that, I think for orthoses, for example, I would look at the smaller systems, right? Personally. Or maybe belt-based printers or that kind of thing, just to keep that kind of low cost as an investment, but also just that also is completely do it on a lower cost system, in my mind. And I think that would also really reduce your prices. So I think, would you agree with me on that one? I think, Brent, or not?
Yeah, I mean, one of the things too, Maurice, I know we've talked about this early on. We believe, and we are starting to deliver SMOs with material extrusion TPU inners and with these frames, and it's pretty amazing, the results. And Maurice, I'll shoot you a text of the latest one that we did, but it now starts making sense, even for some of those smaller things like the SMOs and such, where you can turn around quickly, get them the exact way that you want them, and it's a really neat thing. So the material extrusion side of things and not having to worry about TPU and powder has really been an eye-opening experience. And I would say even more eye-opening over the last 3 to 6 months. And so, Maurice, we hadn't talked probably for that amount of time.
Yeah.
And so you might be due to come up and visit again on some of that, and we're happy to share in some of that. When we look for a small tribe of people that believe in taking care of the patients the way that they need to be taken care of, care about outcomes, and then care about sharing knowledge across some of the platforms, all the while creating your look and feel for your specific company.
So Brent, you sped past something, and I want to go back.
Okay.
So let's talk 3D printing SMOs. Are these SMOs by measurement?
So you can do by measurement.
And if they're not by measurement, how do you get to the final product? Are we saying we scan a cast, then we modify using what software, and how do we get to the end? Because again, remember, that's the challenge. The challenge is getting to the final product and making it duplicatable for every clinician. So most of the people you probably have on this are people who understand the process of 3D print, people who are looking at additive manufacturing, and they're doing it every day. I'm a business owner who's looking to reduce costs, speed up service time, speed up wait time, speed up reimbursement time. So I'm looking for processes, but I can't tell you that every clinician, and this is what is the holdup, and I know we're going back in the conversation, but the holdup is not every clinician is going to be able to do what you do and what Jared does.
Yeah. Well, and I think that's where it becomes so on the SMO side of things, the design. So like for East Point, I can tell you what we do. So, I mean, SureStep does a reasonable job on their smaller ones by measurement, you're like 2.5 inches on the ML at the Met heads. You can get away with pretty much everything. They really struggle, and they know they struggle when it goes bigger than that, or you're going to what they call the big shot or the big shot light.
Yeah.
So at East Point, because those are expensive products anyway, that's where we have started to concentrate as big shot light. Something that if you can get a cast or a scan of one side, we can always mirror to the other side to make a bilateral set. And so that's been kind of our thought process. All the while we're really leaning into and trying to validate our by measurement system to see if we can we can actually have some of the replicatable ones for the smaller feet so you don't have to take a cast. But this was a pain point for us, is we would have big shots and big shot lights that would not fit. And I don't think we're in the minority with that. And so we're like, hey, we're having to go back anyway. If we brought this in-house, we're saving a clinician something. We're also saving costs, and we're putting out a product that's unique to what we do. And that's how we've started. And the by measurement is definitely where we're wanting to get.
All right, guys, I really love this episode. But we need to stop here before first off, Maurice is going to put me out of a job, or if we keep on going, we'll put Brent out of a job.
Yeah.
I thought this was great, guys. I thought this was a really wonderful kind of like, I love your honesty here, Maurice, and just being like, hey, so what works? And I really, really thought this was a very, very valuable episode for people listening. So thank you so much for being on with us today.
Thank you for having me.
And yeah, we look forward to having Jared back and finding out what you guys found, how you're working with the foreign lamps thing and how you're working with the AirFix system. That would be wonderful to figure out like how progress is being made there. So that'd be cool. So we'd love to have Jared on later.
Thank you.
And yeah, Brent, I know you love this, right?
Well, it's fun to have the honesty, and I'm not gonna edit out anything, even like some of the costs and such. And the reason being is that it's always so nebulous, and Maurice can kind of speak to that too. It's like, hey, this is the kind of pricing and that sort of thing, but no, let's get some real live numbers and let's run them and see if it makes sense business case wise, and when does it make sense. And so I think that's where this episode is so valuable.
Yeah, awesome. So thank you for listening to the Prosthetics and Orthotics podcast. Tell all your friends about us, and have a great day.